Today we're going to look at Lesson 15. This comes from sections 2.7 and 2.8 in your textbook. We have two different I can statements or objectives today. I can graph linear inequalities, and I can graph absolute value equations and inequalities. So we're going to be doing a couple different things in this lesson. Again, you should have your notebooks, take notes, do the examples, make sure you write everything down, and then answer the Edpuzzle questions as well. There is a lot of graphing today, so I know that will be more difficult for you to do on your own and in your notebooks. But if you just get the general idea, if you can sketch out some graphs, that'll be good. That will be helpful. But then you can use the examples that I do to help you with your Math Excel. We're going to start with graphing linear inequalities. This is something that you've done before. I know you did it back in Algebra 1. So there are 3 steps. First, you're going to graph the line. Now, you're going to see 2 different types. If it's in slope-intercept form, you're going to graph B, your y-intercept, and then use M, or your slope, to make a second point. Okay, you've done that. Or if it's in standard form, you're going to find your x and y-intercepts and graph those. So like you cover up y, find x, cover up x, find y, plot those on your x and y axis. Step 2 is to decide what kind of line you're going to have. You're either going to have a solid line or a dashed dotted line, okay? So if it has an equal to, it's a solid line. So greater than or equal to or less than or equal to, it's a solid line. That's the same as having that closed circle on the number line. It's going to be dashed if it does not have equal to. So if it's just less or greater, you're going to have a dashed or dotted line. And that's similar to having that open circle on the number line. The numbers are included with the solid or the equal to. They're not included with the dashed or the dotted. Okay? After you get your line graph, you have to decide where to shade, because when we're talking about inequalities, you have a lot of values. You have a lot of values above or below. So on the number line, we drew our arrows left or right. On a graph with an x and y axis, a coordinate plane, you're going to shade above or below the line. So you're going to shade above if it's greater or greater than or equal to. You're going to shade below if it's less, so less than or less than or equal to. All right, and most of the time it's pretty easy to see above or below, but a helpful little hint is to look at the y values. So look above the line and look at the y values, see where the y values are greater. If you see this symbol, if it's less, you're going to shade below. Now, before we move on, I added a little note here for the shading. It's going to be a little bit different for standard form. If you have slope-intercept form, you're just going to look and see where y is greater than, less than, and that's going to tell you how to shade above or below. Okay, for standard form, you're going to look at each little equation that you get when you find the intercepts, and you're going to use that to do the shading on your graph. And I will show you how to do that in the examples. But just know, your shading is not going to be as straightforward for standard form, okay? But I still think you guys will do fine with it. Okay, now we're going to look at some examples here. And I'm just going to work through them. I'm going to explain what I'm doing as I work through them. I think that's the best way to show you how to do this. And then remember, you can go back and watch this as you do your Math Excel work. Okay, so number 1, we have y is less than 3x plus 2. So 2 is your y-intercept, or your B. So I'm going to go to 2 on the y-axis, and I'm going to plot a point. My slope is 3. So that means my M is 3 over 1. So I'm going to go up 3 over 1. And I'm going to do it one more time to make sure I get a nice straight line. Okay, now I'll look at my inequality symbol. This is less than. It does not have an equal to, so that means that my line, oh, and look, guys, you didn't even catch me. 1, 2, 3, then 1, 2, 3. I accidentally made a dot there, and if you all were in person, I know that somebody would have been able to tell me that. All right, so I do not have an equal to, so it's going to be dashed or dotted. You can do either one. Just make sure that it's separated. Now, especially with inequalities, you need your line to go across the whole entire graph. So make sure you extend it across. In Math Excel, it does it for you. Now, less than. So that's going to be below the graph. So I'm going to look at the y-axis. Which side has the lower y values? It's this side. So I'm going to color that side of the graph. Now in Math Excel, you have some little graph tools. You have a bucket of paint that you can pour on the correct side. So that makes it a little bit easier. Okay, number 2, 1 is my B. I don't see an X, so that means my slope is 0. And what kind of line has a slope of 0? Horizontal. So I'm going to go to 1 on my y-axis. And I don't have a slope. My slope is 0, so I'm just going to make another dot out to each side just to help me make my line straight. Okay, looking at the inequality, it is equal to, so that's going to be a solid line, so all the way across. And this one's pretty easy to find above and below because the line's very straight. So greater than is above, so you're going to color above. Okay. And feel free to pause the video on any of the graphs and think through them for yourself or take a minute to look at them before you move on. Number 3 is a little bit different. Notice it's got an X that comes in front. So that means it's a vertical line. And that's your x-intercept. So we're going to go to 7 on the x-axis and plot a point. And it's going to be straight up and down. So I'm just going to make a couple dots to help me make my line straight. All right, and it has equal to. So it's a solid line. Equal to is solid. Now, this is less than. All right, this is similar to looking at a number line. We can't really do above and below here, but we can do left or right. So we want the numbers that are smaller than 7. So the smaller than 7 are on this side. So this is the side that you shade in or color in. Okay, number 4, our B is positive 3. And our slope is 4. So M is 4 over 1. So we're going to go up 4 over 1. And I don't have room to go up 4 and over 1 again, so I'm going to go backwards. So I'm going to go down 4 over 1. Look at your inequality symbol. Is it going to be solid or dashed? Dashed, because there's no equal to. And then above or below. This one's greater than, so it's going to be above. It's where the y values are the biggest. Now, our last 2 are a little bit different. They are in standard form, so I'm going to have to find each intercept. So for number 5, first I'm going to do x. So I have 4x is less than negative 20. I'm going to come over here to the side. If I solve that, I get x is less than negative 5. Okay. The other one is negative 5y is less than negative 20. I'm going to divide by negative 5, and I get y is greater than 4. Okay, so I'm going to go to negative 5 on the x. I'm going to go to positive 4 on the y. Do I need a dotted or solid line? Dotted or dashed. So I'm going to go ahead and do that. Okay, now this is where it's a little bit different than slope-intercept form. So numbers are less than negative 5. So let's look on the x-axis. So where are the numbers smaller than negative 5? Okay, it's on this side. All right. What about y is bigger than 4? Where are the y values bigger than 4? Up here? All right, so this side of the graph is where we colored. So that is the part of the graph that makes your solution. Now, I know that that's a little bit different than slope-intercept form because this is less than, but we colored above. So when you're looking at the intercepts, you have to look at each individual inequality and think about where that would land on the graph. So like we said, this side has values that are smaller, or x values that are smaller than negative 5, and y values that are bigger than 4. All right, now we're going to do the same thing with number 6. So to find the x, we cover up y. So we have 2x is greater than or equal to 8. So x is greater than or equal to 4. Cover up the y, or the x, to find y. We have 4y is greater than or equal to 8. So y is greater than or equal to 2. All right, so we go to 2 on the y. We go to 4 on the x. Is it going to be dotted or solid? Solid because of the equal to. Go across the whole graph. Now, we need the side that has y values bigger than 2, so that's up here. X values greater than 4, so that's over here. So we color above. Okay, so there's graphing linear inequalities. Hopefully, these will help you on your Math Excel work. The examples 1 through 4 were problems that you've seen before, you've done before. 5 and 6 might be a little bit different, but I think that you guys can get those figured out as well. The next type of problem we're going to look at is they're going to ask you the question, is blank a solution? So like here's example number 1. Is the ordered pair 4/5, 0 a solution to 3x plus y is greater than 2? Now, if you had a graph, you could look at the graph, you could find this point and see if it's in the shaded region or not. Okay, but algebraically, we're just going to plug in the values and see what we get. So this is our x, this is our y. So we're going to plug those in. So 3 times 4/5 plus 0 is greater than 2. Okay. 3 times 4/5, that's 12/5. It's greater than 2. Now, in some of your calculators, you can type that in and see if it's true or false. In this case, if we're just looking at it algebraically, 10/5 would make 2, so 12/5 is bigger than 2. So we would say, yes, it is a solution. Okay? Again, you could type that in your calculator. If you do 3 times 4/5, you would get 2.4. So again, that shows you that is bigger than 2. But basically, all you're doing is plugging in x and y and seeing if this statement is true or false. Okay, here's example number 2. Is 5, -2 a solution to -2x plus 2y is less than 10? So let's try it. So -2 times 5 plus 2 times -2 is less than 10. -2 times 5 is -10. 2 times -2 is -4. That's -14 is less than 10. And that is correct. So yes, that one is a solution. Okay, the next thing we're going to look at is an absolute value equation. So first we need to look at the parent function. So the parent function is y equals the absolute value of x. That's the most basic absolute value function or equation there is. Okay, here's the table of values, and basically whatever you put in for x, your y value is going to be the positive of that number. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And it keeps following that pattern over and over. Now, I do have an absolute value equation function graphed here, and I didn't do a good job of going all the way to the edge there, so my arrow's a little premature. But the parent function, your vertex is at 0, 0. You're going up 1 and over 1 to the right, and left 1, up 1 to the left, and it makes a V shape. So that's your parent function. So all the other absolute functions that we're going to look at today are a version of this, just moved around. Okay? Okay, so here's the basic form of an absolute value equation. So this is the parent function. This is the most basic. There's nothing else added. Okay? You can have a number out front in front of the absolute value bars. This is the dilation number. It makes the graph fatter or skinnier. Okay? You can have a number inside with x being added or subtracted, and that tells you how you move right or left. Right is negative, left is positive. And that's a little opposite. But if you think back to the point slope form that we were working with, we said you can't trust an X. And so when we made that form, even though we have parentheses instead of absolute value bars, the same principle applies. You can't trust an X. It's the opposite of what it appears. Okay, so I told you that that point slope form would be the most useful, and this is why. That point slope form is mirrored here in absolute value. And once you're already familiar with point slope form, it makes this form a little bit easier. So when you have a number inside with X, you're moving the graph right or left. And again, you can't trust an X, so it's the opposite of what you would think. So if there's a minus, you're moving right. If there's a plus, you're moving left. And then on the outside, your plus or minus K here tells you to move up or down. And we can trust this number over here. So if it's a positive, you're going to move it up. If it's a negative, you're going to move it down. Now, we will look at how to do those and how to graph those on graph paper, okay? And I will show you what it means. It's really a lot easier than what it might appear here. You're taking that same basic parent function that we did here, and you're just moving it up, down, left, or right, okay? Now, we'll actually do the graph here in just a second, but I think you have a couple problems that ask you to fill in the table of values. So when you do that, you're just going to plug in your X values in for X and simplify. So like for this first one, we would have the absolute value of -3 plus 5. The absolute value of -3 is +3, so that's 3 plus 5 equals 8. Then plug in a -1. So the absolute value of -1 plus 5 is 1 plus 5, and that's 6. Plug in 0, the absolute value of 0 plus 5, that's just 0, so 5. The absolute value of 1 plus 5 is 1 plus 5, and that gives you 6. And the absolute value of 3 plus 5 is 3 plus 5 equals 8. And if you notice, it's like a mirror. That should always happen, okay? And what you'll notice when we graph it, if we think about our shifting, this number is being added on the outside. So that tells us that our graph should be shifted up 5. So you're not going right or left any, you're just going up 5. And when we look at the graph, that is what we should see. Okay, so I don't know, let me try to get this in the same shot so you can see those things side by side. All right, so if I'm looking, I've got -3, 8, so -3 up at 8, -1, 6, 0, 5, 1, 6, and 3, 8. All right, we can connect those to make our V shape. Now, we use the table of values, but we also said that this 5 being added on the outside should tell us that our graph is just moved up 5. So instead of being at 0, our vertex is at 5, and that's what we wanted. So it moved up 5, and then we still have the up 1, over 1, up 1, over 1, up 1, over 1 in both directions. So you can use a table of values or just the equation to graph. And in Math Excel, some of them ask you for a table, and I think some of them might not, but you can do either way. You can always make yourself a table of values, even if it doesn't ask for that. Okay, so let's do some more practice. So here we have y equals the absolute value of x plus 8. So this time, this is on the inside of the bars, and that tells us, remember, you can't trust an x. So the opposite of that would be left 8. So we're going to, instead of being at 0, 0, we're going to go to the left 8, and then I'm going to go up 1, over 1 a few times on each side. And make your V. Now, you could have made a table of values, and you could do X and Y. You could say negative. On this one, you would have to go way over here to see the V, so you'd have to plug in some different values. So like you could say negative 10, negative 9, negative 8, negative 6, and then you could plug in negative 10 plus 8 is negative 2, and the absolute value of that is 2. Absolute value of negative 9 plus 8 is 1, and you could keep doing that, so on and so forth. But probably the easiest thing would be to graph it and then find your values. But I know in Math Excel, sometimes it's picky. It wants you to do the values and then the graph. But if it does that, it'll give you your X values. So they're really easy to plug in. Okay? So number 3, we have this number on the outside that tells us we're going to go down 2. So instead of being here at 0, 0, I'm going to go down 2 and up 1 and over 1 a few times on each side to make our V shape. And I know my graphs aren't perfect. Yours will look much better in Math Excel because it makes the straight lines for you. Okay, so there are absolute value equations. So basically, you're looking at the equation, seeing how it's being shifted, and then you're just plotting that V on the graph. Okay, the last thing we're going to talk about are absolute value inequalities. We're going to graph them the same way we did the equation. So you're going to look and see how your V is shifted, how that graph is going to be shifted left or right, up or down. You're going to plot that on the graph, and then you have to decide if it's going to be a solid or dashed line, and then shade above or below. Okay, so very similar to our inequalities that we did earlier. We're kind of just mixing what we've talked about so far and putting it together in one type of problem. Okay, so we'll look at, I've got us 2 examples here. All right, so number 4, we've got a negative 1 inside, so that means we're going to go to the right 1. Okay, so I'm going to go right 1. I'm going to go ahead and make my dots. Remember, just up 1, over 1 on both sides. Now, look at your inequality symbol. We have an equal to. An equal to means solid or dashed. It's solid. All right, and I need to go all the way across the graph, extend the lines. I didn't do a very good job there, but you all get the idea. Now, is that less than or greater than? That is less, so that means we're going to shade below. So you're going to shade below the shape. Okay, and that's it. Number 5, we have a plus 2 on the outside. That means we're going to move up 2. So instead of being in the middle, we're going to go up 2. Again, do your up 1 over 1 on both sides. And is it going to be solid or dashed? It's dashed this time, or dotted. You can do whichever one you want to. If you want to, you can keep making your dots and use that as your line, or you can actually make dashes. Either one of those works. I know that looks kind of funny, but I'm just showing you, you can do either one. This is greater, so we're going to shade above. So we're going to shade in this little portion. And there you go. So again, very similar to your inequalities, very similar to your absolute value equations. You're just mixing those together. So use these examples, use these notes to complete your assignment in Math Excel. If you need help, let me know. I would be happy to assist you, happy to help you in any way. Just hit that Ask My Instructor button or send me an email. Hope you guys have a great day.